Okay, I think we can start. So the first speaker in this session is Karishma Punwani from MapleSoft, and she's gonna talk about the next steps with MapleLearn and the Maple calculator. So Karishma, yours.
Thanks, Nadia. Let me share my screen. Hopefully everybody can see that. So good morning, good evening, good afternoon, depending on where you are around the globe. Today, I'm going to just give you a little bit of an overview of what I presented in my talk, which was entitled Next Steps with MapleLearn and Maple Calculator. And a big thanks also to Nadia, who helped me create the video for the talk as well. So what I wanted to do first is just kind of give you an overview of where MapleLearn and Maple Calculator fit within what we're calling the Maple Math Suite. So we have Maple, which is a beloved product known by probably every user attending the conference. And then earlier this year, we launched MapleLearn. And we launched MapleLearn really to help students as young as in high school to develop an intuition for mathematics. So Maple has been a beloved tool. A lot of students are first introduced to Maple at the university level. And in talking to instructors, the sense was, we love Maple, but sometimes our students are a little bit overwhelmed by just whatever, everything that Maple has to offer. And so we launched MapleLearn, which is an online tool, and it complements Maple. So the idea is that students could use MapleLearn and then progress to Maple if that's where their studies take them. And then the Maple Calculator. So the Maple Calculator we launched 2 years ago. And again, the Maple Calculator connects with both Maple and MapleLearn. And it was built for students, again, to empower them, to give them the ability to check their work, to see steps, to help guide them and figure out where they might have made a mistake. Since we've launched the calculator, we have over 600,000 active users. It's completely free. So if you haven't tried it, take a look. And one of the things that I've noticed, which was really interesting, is when we first developed the calculator, it was geared towards students. And then we've had just resounding success and feedback from both researchers and engineers. So I really would say it's for all users at any spectrum. If you're doing math, I think you'll find Maple Calculator to be a really valuable tool. So I won't talk too much about Maple. Let's focus on some of our newest products, which is MapleLearn. So MapleLearn, as I mentioned before, it's an online product. And what it allows you to do is to, type in an expression and immediately, without any commands, see how that expression responds, how it looks. So you can graph curves instantly in MapleLearn. A nice thing about MapleLearn as well is that you can share your documents with anybody. And I think in Laurent's session, I saw a lot of feedback saying people found this to be one of the most, or one of the features they like the most, right? So a student can use MapleLearn to work through a problem line by line and share it with somebody else if they're stuck. The other thing with MapleLearn that's nice is that, you can parameterize expressions very easily with the click of a button. And what makes this useful is that you can create interactive applications. And what I find this does often in showing this to different educators and students is this is where they can sometimes have that wow moment. They can see what happens as the input changes. How does the function respond? In terms of math, so MapleLearn is capable of doing math all the way up from, I would say, high school to first, second year university. And Paul is actually going to share more details on how MapleLearn connects with Maple. And so you can actually create scripts and take advantage of more of the Maple language in order to do things in MapleLearn. One of the other things that I really like about MapleLearn is, it's different from other tools because MapleLearn takes I would say, more holistic approach to solving problems. It's not just about the graph. It's about taking notes. It's about solving problems line by line. You can get the answer with the click of a button, but you can also work through the problem. And one of my favorite features, Laurent actually demoed this on the fly in his presentation, is that you can take a picture of a handwritten solution and bring it into MapleLearn so you don't have to redo everything you've done. Let me show you the Maple Calculator. So the Maple calculator lets you enter, basically, you can have a handwritten expression, take a picture of that expression, and Maple calculator will give you results for operations that make sense for that particular expression. Maple calculator is really kind of borrowing off the idea of the context panel in Maple. And you'll see here I have a differential equation or a limit. It gives me the solution, the plot, all of these different things. The calculator is unique. It gives you 2D and 3D graphs. Not only that, it allows you to send your result to Maple, as I'm showing in the video right here, but also to Maple Learn. Everything is powered by the Maple engine. So what the Maple calculator can do is beyond what a lot of other calculators give you the option to do. And as I mentioned before, the Maple calculator is completely free. I see there's a chat message. So I want to quickly show you Maple Learn in action. So I'm going to stop sharing the PowerPoint and hopefully. So over here, I have Maple Learn, and Maple Learn, you don't need an account to start working. It's completely free. So with Maple Learn, and in my training session, I gave you more details on how to use Maple Learn, and Nadia and I offer training sessions. But something that I love is this free form environment for entering math. So, let's go ahead and enter in a quadratic expression. Notice how I'm typing. The plot is automatically appearing. I can go ahead and assign this to a function, and I can evaluate this at a point. If I wanted to, I could evaluate this for different values. Now I can move the slider. So as soon as I have a numeric value, a slider automatically appears. With Maple Learn, I can move things in the canvas, so this becomes clear. Let's say if I want to factor this. So here's my function. Notice over here, I didn't have to redefine it. I have my function over here, and I can continue to factor it. So I can factor it line by line. And then over at any point, let me just do that. And at any point, I can say, use the graph. And I can say, oh, clearly I've made a mistake somewhere. If I need help, click on this, use the context panel. And I can say, okay, well, factor this expression. It gives me the result. It also gives me steps so I can see where I might have made a mistake. With Maple Learn, again, I can move this around. If I want to, I can embed the plot here. I can also add some notes. So now that's one particular example. With Maple Learn, you have access to units. There's a geometry palette. There's a palette for adding tables. Now, Paul is going to show you some of the features that you can do with scripting in Maple, but I'm going to leave you with my favorite scripted example. Let me see if I can find it. And this was created when one of our brilliant co-op students. And here you have a document. Notice that there's images, and I can drag this in, click a button, and it tells me how much of my budget I have left. So I got a remark saying I'm at the 8-minute mark. Are any questions?
Thank you, Karishma, for that. So we had a question of someone asking if the Maple calculator was available on Android. So
yeah, the Maple calculator is available. Again, it's for free on the Google and Android store. Just search Maple calculator and you should be able to find it and install it. And if you like it, please leave us a review.
Someone asked also, can you also import matrices from the calculator to Maple Learn and perform calculation on it?
Yes, you can. So again, just all you have to do is if you have a handwritten expression, or even if you've typed in your matrix on your calculator, in fact, it'll automatically, as soon as you enter it, be available to you in Maple Learn, as long as you're signed in to the calculator and Learn with the same credentials. And you just click this little cloud expressions icon, and it'll be available to you ready for use.
And one last question before we go to the next speaker. So someone is asking about the premium. So what is the difference for, I think you can generalize for both MapleLearn and Maple Calculator.
Yeah, so all of both the calculator and MapleLearn are completely free to use. We do have a premium tier, and in both cases, the premium tier just gives you unlimited access to all of the features. So it's not that the one product has less features than the other. I should say one tier has less features than the other. The difference is just giving you unlimited access. And so that's the difference with Maple Calculator. It kind of has to do with steps. And with MapleLearn, there's a few other things in terms of context panel operations and saving documents.
Perfect. Thank you very, very much, Karishma. If you have any other question on this talk, just pop them in the Q&A and we'll reply at the end if we have time. So next speaker is Paul DeMarco from MapleSoft, and he's gonna talk about his presentation on creating and sharing interactive web content with Maple and MapleLearn. Paul, yours.
Yes, let me share my screen. Okay, so you've all seen a little bit about MapleLearn, which is a web product available if you have an internet connection on your tablet, on your phone. Well, it's getting better on the phone or in your browser. So what I'm going to talk about is how to use Maple to, increase the power of what you can do in MapleLearn. So the first example I'm going to show is this one, and I'll start by just showing it. So the idea here is that I've got an instruction and I've got a button, and I'm just going to type some numbers everywhere on the screen. And now I click that. So the key here is this button is going to let me run some Maple code. I'm going to go back here and show what's happening. So here's my canvas description. So I've actually created the canvas here in Maple, just simply giving a string here that's going to be this caption here. And here's my button, and it's going to run this find primes code. So the find primes is going to create a script. It's going to loop through all of the math in the canvas. And then for each thing, it's going to look at the values. So if this is a value happens to be an integer and it's prime, then it's going to put this annotation on. Otherwise, it's going to put this annotation on. So that lets us run any Maple command basically in Learn. So what can we do with this? Here's another example, and I think it's always best to just show it first. So here I've got a title, some text, a list of numbers, and a plot, and a couple of math equations down here. So I'm just going to go ahead and press the calculate button. So that's fed all these numbers back into Maple, created a histogram and a normal distribution based on this data. And then I can go in and add my own numbers or change the list and recalculate. And we can see how adding a grade of 0 into this list affects the distribution, the mean, and the standard deviation. So again, here's our canvas description. So we've got that title, we've got the text. G is this list of values here. We put in a placeholder for the plot and some math and a button. And the button just runs some Maple code. So it's calling the statistics mean, variance, it's producing a density plot and histogram. So it's done these calculations, and then we're going to put those pieces back on the canvas. So let's look at another example. So here we are going to have a couple of differential equations, and when we plot this, we get the direction field plot. And this is, again, it's a live thing, so I can change my equations and replot it. So again, I created this in Maple. So I've described the canvas, some text, a plot, and a button, and the button is just using the dfield plot command. So this starts getting really interesting when we look at what else we can do. So seeing you can leverage some Maple commands, but let's take this a little bit further. This is the example from Laurent's keynote. So where we have a solve command, and then we just let the student, my caps lock on, progress through this. So say 2x equals 4 minus 3, and then x equals 1/2. And I can click the check my work button, and it'll go through and say, hey, I got it correct. And I can click try another, and it's going to clear my previous answer and give me another linear equation that I can solve. And linear equation I've just used here because it's easy for me to type the answer and show you, but this can get much more sophisticated, including integrals and other kinds of problems. So how does this work? So here's my Canvas description. I've got the solve title. I put the math for the equation, for the initial equation, and then the check my work and try another buttons. And the try another is just going through. Its key thing is this generate similar. So it's just taking the existing expression, and we have some built-in functions in Maple that will take an expression and give you something that looks similar to that expression. And it's actually pretty sophisticated for all kinds of expressions, including differential equations and integrals and whatnot. And it will try and find an expression that has, for example, integer roots and things like that, so that they're nice. Or you can customize this to give exactly what you want. So there's the share canvas command once I've created this, and then I can deploy it. So we have also some higher level commands that don't get into definitions of Canvas or anything like that. So we have a quiz command and a number of others. So here is sort of an advanced level quiz command. So I'm giving it 3 procedures: one to initialize, one to check the response, one to initialize the problem, and one to show the solution. And it's going to replace these $A and $B variables in the question. So let's just click this link and show how it works. So here I can click try another. It's going to go replace the input with new numbers. I can enter an answer, and I don't think this is going to be correct. No. So how do I do this? I click slow solution. And it's going to show me what this is all about. So here we have kind of a complex application here with 3 buttons, some layout, some math, some complicated math. And the number of lines of input here is actually very, very small. So if you know Maple, you know how to write a procedure, and it's just calling this quiz command to get the student's response and comparing it to the binomial of the A and B that are on the page. And here for generating a new problem, we're just setting A and B to new random numbers in a certain range. And the show solution is just laying out the binomial coefficient. I'm going to show one more example. I really like this one because it's sort of the most similar to what you would get in a real pen and paper environment from a test. And it's just you type in whatever you want, you're given the problem, and you can, for example, say let X be ... the one pipe, and let Y be the other pipe, and then you can start answering your question by developing your system and click the check my work button. Okay, so I see we're at the 8-minute mark, so I will open the floor for questions.
Thank you very much, Paul. So we have few questions in the chat. One that is actually quite interesting. So someone is asking if you could do the opposite. So create a canvas in Learn and then produce the appropriate Maple worksheet.
Actually, yes, you can. You can use Learn to create your canvas, and then you can pull that in as either a piece or the whole thing inside of Maple. And you can actually, so if I go back to Maple, let's just take this normal distribution one. So there is the share canvas command, but there's also a show canvas command. So I can actually run everything here inside Maple. Now it looks a little bit different, but this is actually very important for prototyping your example and making sure you got the procedures right. So these things actually do work inside of Maple as well.
Thanks. So someone else is asking how fluent with the Maple language you need to be to create such a nice looking document.
So definitely you need to be on the latest version of Maple, and actually some of the features I showed are as yet unreleased, so they will appear in the next version of Maple. But a lot of this is there already in the latest Maple 2021.
Thank you. And just one last question. So someone is asking, are there any step-by-step solutions available in Maple that aren't available in MapleLearn by scripting yet?
So Maple actually is the source of all of the step-by-step intelligence. So we are currently working on extending and adding new step-by-step algorithms. So right now there are actually quite a few that are in Maple, but not yet in Learn. But Learn is rapidly evolving, and we're improving it and adding to it, and we hope to get all of those step-by-step solutions available in Learn and Calculator.
Perfect. Thank you very much, Paul. If you have any other question for Paul, please put them in the Q&A so then we can ask them at the end. So next speaker is Douglas Meade from University of South Carolina, and he's going to present us his talk on creating and using customized MapleCloud-based tools for classroom and student use, and more specifically on differential equation. So Douglas, you can share your screen and start.
Thank you very much, Rochelle. Now, of course, my throat's going to act up. So let's see. I think I probably want to share that screen. And do you see that now? Let's get rid of some other stuff here that's not.
Yes, we can see it.
Oh, I did want to see that. Okay, so I did want that window. All right, so I guess I had, when I submitted the abstract for this talk, let's get back to the beginning here. I had thought that I had hoped that I would be able to. Now you should be able to see it better. Okay. All right. I'd hoped to be able to show some things in MapleLearn as well, but my schedule didn't allow me to quite do as much playing with that as I wanted to. But I'm certainly looking forward to redoing a lot of what I've already done with the new technology available in Learn. I think that's going to be so much more. But I'm hopeful that what I've done with right now with the embedded components will also be helpful as I undertake that process, that my work can evolve and not have to just be recreated. And so if you watched my video, or if you're watching through here, I had a number of examples of things, of resources I made available for my students to practice some common techniques and ideas from differential equations, different things with graphs and different things with finding explicit solutions, just to try to improve, give them more experience with things. And these are all available in the Maple Cloud. I find them by searching for my name, and we see a good collection of those here. You see the last couple of years, some of the ones earlier this year. Yeah, that's where I get access them originally. Here's some screenshots showing them. So this, and I just want to show some basic ideas here. And I think I think it's probably most interesting to spend most of the time, if I can, showing how I actually create the interaction and build these elements. And so what we see here is we have a system, x prime equals ax, and I've got an array kind of kludgy here of, and I think with Maple Learn this will look much better. I can change my matrix, and I have a parameter that I've put in here, a slider, and that slider is down here. This is a static picture, so this isn't going to work. But then it shows the direction field for that value of alpha. And then I can select different initial conditions and have those curves plotted in there as well. And I can control some things about the graph. Another one for locally linear systems, where we find this one helps the students to see how to find the equilibrium solutions as intersections of the different null-clines. And then do the linear analysis at each of the equilibrium points. And again, you can enter your equation. You've got a slider here, one parameter, so you can see how that parameter changes the problem. No graphs here. This is just for looking at particular solutions. The idea of finding particular solutions to try to lead up to the method of undetermined coefficients to give experience, finding a homogeneous solution and seeing how that influences the guesses that you might need. Another one here, again, this one is more interactive for the student to enter things as they work through that they enter their, or they see the process. They don't have to enter it. Just going through the process of making a guess, finding they can't enter the guess, then they plug it in, match the like terms, solve for the coefficients, and then find a particular solution if it's going to work. This one was probably the most sophisticated one that I've written mathematically in getting Maple to match the terms and do everything the way we want it to. So I'll see if I can maybe show more about that in a second. Now back up again, visualizing the phase plane. So two different plots of the same problem. Again, and I can slide time through to see that. And then a response to a forced oscillator, seeing the effect of resonance. And so I think what I want to do now is you've got all these slides and all this stuff here static, so you can see that. I don't need to read it to you. I'm going to come back to Maple, and I hope, and do some things live now. All right, so here is the undetermined coefficients. I guess I can even come up here and fix the spelling up there. Right, and so we have a problem. I can change the coefficients. I can change the right-hand side. And then I can update the problem. And we see that the problem did update. And I have, well, it didn't change my homogeneous solutions, but I have those. And now I can enter my guess. And if I want to do things like that, I can plug it into the differential equation, right? And I guess in this case, if I match like terms and solve for the coefficients, it shouldn't find a solution because I changed the right-hand side and didn't change my guess. It doesn't tell me why it doesn't match. What I see here, I've got a -1 = 0 for one of the terms, right? So that system isn't going to have a solution. But if I come back up here now and I fix, let's see, I changed that exponent, and I did take away, well, let's do it this way. I plug that guess into the system and match terms and solve for the coefficients. That one should have had a solution if I did things right, but this is not completely foolproof. I really should have been able to get rid of that. And I must have made some kind of a, okay. All right, well, that's what you get with live demos. This usually works, but what did I change? All right. So, all right. But what I want to really emphasize in this is how you create this interaction. And so if I come and I look at I put everything in the startup code. So that, well, these are buttons, and I can see the code for the button is just to run this update problem script. And that updates the problem. This button is going to run the plugin script, and all of these procedures are defined in the startup code. You could put the code in the button itself. I find that harder to manage. So here is the full code for this problem. And you see the update problem. It pulls in information from different buttons and math containers. Then in the parameters of the problem, it creates a differential equation. It finds the homogeneous solutions, plugs those, and then puts those back into the relevant parts of the interface. And I think the MapleLearn is making all of this much, much easier. So I'm really looking forward to seeing how that's going to work. And then there's a different script here for each of the different buttons. The plug-in button gets the information that it needs, plugs the guess into the differential equation, simplifies things and collects things, and then gets the updates the appropriate elements here. The ones that have sliders, I mean, you just pull the information for the slider, and you can push it. Yes.
You run out of time. It's been.
I'm out of time altogether. Okay. Well, so this is the way embedded components work, and that's where I'm happy to interact with anybody who has any questions about this, and I'm really interested in seeing how I can move these into the Learn environment, because I think the interface and the programming will all be much easier and more powerful. So thank you for your patience and for my using over my time. Thank you.
No problem. Thank you very much, Doug. So for anyone who has questions further, please put them in the Q&A button. Otherwise, you can join the networking session later on and talk to him. So our last speaker for this session is Samir Khan from MapleSoft, and he's going to talk about how to engage your student in the engineering analysis using MapleFlow. Samir, you can share your screen and start. We cannot hear you, Samir. You are muted.
Sorry, can you hear me now? Perfect.
Yes.
Thank you very much, Nadia, for the introduction. So my name is Samir Khan, and I'm part of the Maple product management team here at MapleSoft. I primarily speak with scientists, engineers, and other technical professionals to help them better understand our tools, technologies, and services. Earlier this year, we released a new product called MapleFlow. It's a tool for doing math and calculations. However, it's aimed purely at the needs of engineers and scientists, so people who need to use mathematics to solve technical problems rather than those who want to research or learn mathematics itself. So MapleFlow is a free-form scratchpad for mathematics and documentation. As I said, it's designed for users who want to apply math to solve problems. In fact, they probably don't even regard themselves as mathematicians. They probably describe themselves as scientists and engineers. They're more interested in the application of math rather than the math itself, and they probably don't need all of the power, the flexibility, and the utility of Maple. Their needs are probably rather more prosaic. So MapleFlow is really aimed at the broad base of the pyramid who need a simple to use, easy calculation tool. So throughout the next couple of slides, you'll probably see a few videos playing, and these are simply sped up videos of me doing a few calculations in MapleFlow. So throughout those videos, you'll see a number of features. So it has a freeform scratchpad layout, so you can place math, text, images, and plots anywhere on the canvas. A canvas is what we call the MapleFlow worksheet. It evaluates math left to right, top to bottom. That's forward in space. That's very unlike the forward in time evaluation model implemented in Maple. MapleFlow worksheets update automatically by default. So as soon as you change a parameter value or change an equation, that change cascades down the length of your MapleFlow document, and all of the results and dependencies update to reflect the new parameter value. And you have access to nearly all of Maple's math functionality. There are some bits we've lopped off at the top, mostly because we wanted to simplify MapleFlow's interface. So when we first started developing MapleFlow, we had a distinct philosophy in mind. Engineers and scientists, they have a low tolerance for complexity in software tools. They don't want to spend time thinking about how you can navigate around a fully featured mathematics tool like Maple. They just want to click, write down a few equations, and do their mathematics. We wanted the canvas to evaluate automatically, so you don't have the cognitive overhead of having to press enter or update the entire worksheet. We also made some simplifications in the equation editor and the syntax as well. I like to think that MapleFlow has simple game mechanics. The way that you interact and use MapleFlow is simple. But within that simplicity, you have lots of creativity. You can do many, many different things. I also like to think that we've managed to reproduce the tactile feedback that you get from working on paper. The most natural working environment of all is just a piece of paper and a pen or a pencil. You can start jotting down notes, writing equations, drawing diagrams anywhere on a piece of paper. And we wanted to reproduce that look and feel in a software tool. And I think we've successfully done that. So many of you are familiar with Maple, and this is how we see engineers and scientists and mathematicians using either Maple or MapleFlow. So Maple is your tool if you want to do mathematically oriented work to support advanced engineering. So if you're an engineer who actually wants to derive some equations, solve some partial differential equations, or model first principles physics, then Maple is the right tool for you. However, if your mathematical needs are rather more prosaic, rather simpler, and that's the broad bottom base of the pyramid, then MapleFlow is designed for you. It has a paper-like environment, so you can just click and start doing math anywhere. It feels very much like using a whiteboard, in fact. In fact, whiteboard was our internal development name for MapleFlow, and it's really designed for quick design calculations and scratchpad math. So what I'd like to do now is just quickly dive into MapleFlow just to show you what it looks like when you start using it. So this is what the MapleFlow home screen looks like. So I'm just going to start off by showing a complete application, and let's start off with this one. So this is just one of our standard demos, standard worksheets for MapleFlow. Everything you see in here is in a container. So this equation is in a container. You can move this about on screen. All my text and images are in containers as well. In fact, you can create containers anywhere. So if you just click there, you can start typing, doing some math. using the Maple programming language to solve your equations and so on. As you scroll down, you see at various points I have images, commands from the Maple programming language, and at the bottom of my document, I have my results. So as I said earlier, the MapleFlow document updates automatically. So if I change, say, this design altitude for my supersonic wind tunnel to 5 kilometers, that change cascades down the length of my MapleFlow document, and all of the results, dependencies, update to reflect the new parameter value. Now we've developed a few neat features in MapleFlow to help you create interactive technical documents. So what I can do is actually collapse most of the middle portion of my document by inserting everything in a section. Let's go back up and collapse this section. And you see the section lines there, but if you want to simplify the look and feel of your worksheet, you can actually suppress their display. So now when I change my design altitude or any of the other parameters, the power of the supersonic wind tunnel at startup changes. You can see that change there instantly. Now, MapleFlow has two true print layouts. So if I go to View Print Extents, that shows me the boundaries of my chosen page size. If I now export or preview this, this is exactly what I'll see when I convert this to a PDF or print out a hard copy. So that was a very brief introduction to MapleFlow. Certainly, we've found that at universities, we often have professors teaching engineering courses who need a very simple scratch pad just to show some simple engineering concepts on screen. And MapleFlow is certainly designed for applications like that. Professionally, we have customers and users who want to create complete design documents that they submit as a deliverable to a client or share within a colleague. And again, MapleFlow is the right tool for that. So that was everything I wanted to talk about. I know that's a very whistle-stop tour through MapleFlow. Nadia, do we have any questions?
Yeah, actually, we had a few people who saying MapleFlow is excellent. It's fascinating. So a really good feedback. We got one question. Someone is asking, does MapleFlow offer support for all Maple's libraries?
It offers support for 98% of what's in the Maple programming language. There are some Maple packages that we do not support, simply because we wanted to simplify the MapleFlow interface. And by including support for that additional 1 or 2% of Maple packages, we'd have to make the interface a little bit more complex, and we didn't want that. As I said, MapleFlow is really designed for the broad base of technical professionals, engineers and scientists who have rather more prosaic, simpler mathematical needs.
Perfect. Thank you very much, Samir. So we have literally 4 more minutes before closing this session. So there was a question for Paul DeMarco that we didn't have time to ask. So Paul, someone is asking you, does MapleLearn recognize all Maple packages?
I would say the same as what Samir answered. I'd say 98% of the commands, maybe a little bit less than that, because MapleLearn is a little bit newer and is web-based. So maybe 90% of Maple commands that can compute a result or generate a plot, we can show those in the Learn interface.
Thank you. And one last question that is for Samir. Someone is asking you if you can insert a table into this canvas and control the order of execution.
That's a great idea, and that's something that we're certainly considering for future versions. At this point, no.
Okay, perfect. So that's it. We no longer have questions. So I'd like to just thank our 4 panelists. So thank you very much, everyone, for joining the session. And if you'd like to discuss with anyone, please feel free to join the networking session at the end of the day today. So thank you, everyone. Bye.